So last time we just covered some basic idea of, I'll go back into this phrase in a second. Basic idea of working with limits, and we were dividing by the numerator and denominator by the highest power of x in the domain, and that took forever. So this problem takes 5 seconds to know. At infinity, polynomials following the leader. And I'll be teaching this way from now on. I like it, but you will see in the books dividing by the highest power. You can do it too, I don't mind. So I can show you on the graph that polynomial, so this is polynomial of the numerator, polynomial of the denominator. And then we have a ratio. At infinity, polynomials give you infinities. They grow up or down, plus or minus. So they like comets flying into the space. The ratio means they competing with their speeds. Who is faster, the guy at the top or the guy at the bottom of the fraction? Numerator, denominator. So we comparing at infinity the speeds. Well, the speed of the top depends on the speed of the highest term. 3x is infinity, 3x at infinity is infinity, but it's not as fast as 3x to the 5 at infinity. Make sense? So all terms after 3x to the 5, let me put it in some kind of green color, are following that leader. Whatever that leader does, that's what everyone else do. So it's kind of like a comet with the tail. We don't care. That looks like something else. But we don't care about those things, especially minus 10. Even if it's minus a million, it's a constant versus expanding infinity. Nothing to do with, the constant will not change at the end where the infinity goes. The constant might change the sign. What was that number? Do you think I remember? I don't remember. Oh, it's minus 4. So find the leader of the top. It's x to the 5 and it's multiplied by 3. Don't lose 3. It might matter and it will matter. Find the leader at the bottom. They're not always at the front, by the way. In your homework, we're going to try to trick you. I did not create homework. It might be hidden in the middle. Minus 10 x to the 5. That's it. Like you legally can write down the equal sign at infinity, but only at infinity, between this long fraction and the short fraction, leader over the leader. That means we're comparing two speeds and we're only comparing leaders. It makes sense. Others will follow the leader. Now you simplify, if you can, usually can, 3x to the 5 over minus 10x to the 5 gives you minus 3 over 10. That means the speeds were the same up to a rate, constant rate. The top speed was times 3, the bottom minus 10. So the answer became the same times minus 3 tenths. That's the idea here. So what we say, find the leader of the top. Well, I say it this way. Find the leader of the bottom, and the answer will be the ratio of the leading coefficients if the powers are the same. So let's write down this phrase over here, and I will show you all other examples in it for your homework. Can you copy that? It's in my notes, but I finally could summarize it verbally, what I'm trying to say. Find the leader in the numerator. I'm saying leader of the top, but it's not professional. It's supposed to say numerator, but it's freaking long to write, so at the top. And the leader in the denominator at the bottom. If the exponents are the same, that's the best case. If they are the same, this is what we just had. Then the answer is the ratio of the leading coefficients. The ratio of the, because everything cancels out. And again, it's like two expanding universes. Which one is faster? We find the ratio of their speeds. If they have the same speed, you just need to check the coefficients in front, leading coefficients. If the top wins, and what happens if the top wins, the numerator, or the bottom wins, denominator? Now those are different cases. So again, we have a fraction. And we have infinity over infinity, polynomial over polynomial. But they are not the same. That's why it's not 1. This infinity might be to the 5, and this infinity might be squared. Now one obviously expanding faster than another one. It's like expansion. Who wins? Top wins. So you will have infinity. But now it's kind of not very clear if it's plus or minus infinity. Or sometimes you will have D and E. If from the left it's plus infinity, from the right is minus infinity. Or basically when they don't meet. So if the top wins, let me put it in yellow. If the top wins, the answer is infinity or D and E. D and E when left limit did not meet right limit. When the bottom wins is also the best case. If the bottom wins, you end up dividing something like this. Infinity to the 5 over infinity to the 7. Well, the denominator blows up faster than the numerator. So you end up dividing by the hugest numbers you know. And it gives you, this is 0, the smallest number you know. So that's actually the easy one. When the bottom wins, you should feel happy. If you have an infinity in the denominator, then you know that everything shrinks to 0. So when denominator explodes to infinity, the fraction shrinks to 0. That's the idea.
When you said the top wins, the answer is either
plus or minus infinity or D and E.
when we're trying to look at it at the left and right limit, how do we evaluate that?
Yeah, I'll show you an example. Very good question. The question was, how do we know like this? Like I just mentioned those 3 cases, and then how do you actually practically solve it? We're going to do it. Thank you for asking. Very good. So actually very interesting also that the case number 2, let's maybe call it case number 1, case number 2, case number 3. Case number 2 is a vertical asymptote. That's why it's plus infinity minus infinity, like we had on the picture at the very end. Did you finish copying this? Remember, this is only for the infinity. Don't mix it with x approaches 7. Polynomials follow the leader? No. At 7, who knows what's happening at 7? At 0? No. So numbers, functions behave differently, different numbers. But in the long run, that's the official terminology. In a long run, that means x goes to plus or minus infinity, very, very far to the future or very, very far to the past. That's where we know some behaviors. So very interesting, I keep saying that the denominator blows up. That's official terminology too. Blowing up means some kind of mathematical explosions basically mean some singularities, irregularities, infinities. So it's pretty cool. We're going to go into that more. While you're copying it, or maybe you finished copying, I will tell you the interesting story, which is a real story. I always tell it when I mention that something blows up. Mathematicians were going to a conference in America. If this story only makes sense in America, you will see in a second why. So mathematicians were going to the conference, and they were already at the gates and talking about the research they're going to do. So they met there. Oh, you're also going to a conference? Yeah, me too. So they start talking about the research, because that's what we do. We usually open the books like, no, and they start arguing, because usually it happens. They start arguing, they kind of get noisier and noisier, and they're like, oh, no, I'm telling you, it's going to blow up. The solution's going to blow up on the plane. And like, no, it's not going to blow up on the plane. No, I'm telling you, everything goes to infinity, it's going to blow up on the plane. So they got arrested basically very fast, and because something will blow up on the plane. And then, it's a real story. It happened, I think, 8 years ago. And then American, security was very picky about that. So they were questioned for 4 hours. They missed the plane, they missed the flight, everything. And the thing is, like, they show the books and the notes, but because it looks like gibberish, they don't really prove anything. So it took them 4 hours to investigate who are those people, are the dangers and the terrorists, and then they would go. So the story became famously known in the Mathematical Society, and we all were instructed not to talk about our research when we travel in American airports, to avoid this stuff, to avoid accidents. So I was traveling to Ukraine and home, and I was doing at the moment mathematical epidemiology modeling of Ebola in America, specifically Ebola in Texas. So when people would ask me, when security asked me what do, I said, I do differential equations. Like no comments, because I literally was exploding idea if we can prove mathematically if there can be epidemic spread in America of Ebola or malaria. And then that also kind of sounds like who knows what. So we were instructed not to talk about it. We don't talk about Bruno. Example 1. So now I will write it down and you quickly tell me what is happening. People who know this material too well, let other people answer. So other people can participate. Minus 7x to the 5 minus 15x squared plus 10. X squared minus 13x plus 1, and how many zeros you want. Does it matter? X goes to infinity equals. While you're copying, I'm writing down the next one. I will have 3. Limit as x approaches infinity. Minus 7x. Let's do square plus 15x to the 5. X minus 13x to the 8 plus 10. This limit. And one more. Those are the easy ones, and I will show you why they're easy right now. 24x squared plus 2x plus 1 all over 16x to the 4 plus 3x squared with a square root. X goes to infinity. So these are for now the easy one, and then the square root, the one you mentioned, as the hard one. I will do it in a second too. Let's wait for a second, and then I will ask, again, people who know it too well, just let other people speak up, because it's more interesting this way. Fraction, you see 2 polynomials. I told you polynomials go to infinity plus infinity, but the following the leader. What is the answer of the first limit? Minus what? Minus infinity, or plus infinity, or 0, or 7. So let me tell you how I try to teach you how to be fast on the exam. The way I explain you is the way the book follows. You divide by the highest, you divide by this. You just do all of this kind of algebra stuff. I don't do that, so you don't have to either. But if you want, you can follow the book. It's fine. It's actually more professional. So find the leader of the top. Who is the leader of the top?
Minus 7x.
Minus 7x to the 5, agree? Who is the leader at the bottom? X squared. It is legal to write down the equal sign between limits, not between fractions though, only between limits, because limits, they are limiting positions. So minus 7x to the 5, x squared equals, now you literally can simplify, and it will be, well, minus 7x cubed over 1, x at infinity. And now you plug in infinity. By plugging in, you're literally plugging the biggest numbers you know. You can actually check. If you plug 1 million, what's going to happen? It will be infinity cube, which is infinity, minus 7 makes it minus infinity. Does it make sense? So the rate in front matters in this case. Because when you multiply, if you remember transformation of functions in precalculus, when you multiply by the negative, it reflects everything. So whatever was going up will go down. Whatever was going down will go up. So that sign matters. In general, I just look at this, and I'll show you using my hands. You take your hand. Oh, wow, that's like a huge hand. And you shrink it and go down. Okay. So the way I see it, I take my hand, and I like hover this all without writing it down. And then I just see the top wins. It's just freaking fast. X squared and x to the 5. No way it can beat x to the 5. The answer is infinity times minus infinity. That's how fast you can do it. So on a test, it's the best way to do it. My students always are the fast on the tests and in other classes. Okay, let me ask people at the very back. People at the very back. Who is the...
Please zoom out for a second. Zoom out.
Oh. Like this?
Yeah. Thank you.
People at the very back. Who is the leader of the top of the second example? People at the back. So who is the leader of this fraction, polynomial? 15x to the 5. Correct? Everything will follow 15x to the 5, not minus 7x squared. Not because it's in the front. Speed matters at infinity. Who is the leader of the bottom? Exactly. Minus 13x to the 8. So we're comparing those. Do I want to write down everything carefully? No. It's too time consuming. What is the answer? Who wins, the top or the bottom? If the bottom wins, you have infinity at the bottom. It explodes by it in the denominator. So you're dividing by a huge number. It gives you what? 0. And actually, you can check. If you don't trust me or you hesitate during the test, take 1,000 and plug into this fraction and see it gives you huge number and what sign it is, or it gives you small number. It will be small. It will be 0.00753, whatever. That's how you know. Who is the leader of the top of the third example? 24x squared, not 2x and definitely not 1. Oh, did I tell you that nobody cared about this constant? So again, it's a big number, but it's a constant. At infinity, it's still the same number. Other numbers already went to billions, and this thing is still the same. That's why it doesn't matter. The leader of the bottom.
Only x.
Yeah, let's choose it without simplifying. 6 and x to the 4 is faster than 3x squared, so I will circle that. But I will also circle the square root. Here it is.
So would that become, because the second 3x squared is irrelevant, it just becomes 16x to the 4th square root, which is...
Yeah, exactly, which is
4
4x squared. Yeah, exactly. So, very good point. I take my hands, again, and I cover in my mind this and this. I find the leader, And now I can rewrite the limit in my mind or not in my mind and simplify it. Ooh, it was very sticky. Should not have done that. I forgot, for some reason, all the screens are very sticky. Now I can rewrite only the leaders at the infinity. Polynomials only follow the leaders. So I write down 6 next to the 4, but it was inside of the function of the square root. So I cannot just drop it. That's just rude. Don't do that. Now you simplify and see what happens. When you simplify, you have the speed of the top. So remember, it's kind of like a comet flying with a speed x squared. The denominator flying with a speed x squared as well. Do you see that? So the speed of the top matches the speed of the bottom. What's the answer? 24 over 4, or 24 over square root of 16. I will write down it carefully, but I would stop here if you can see the answer. 24x squared, 4x squared. Boom. The answer is the ratio of the leading coefficient, which is, that's the hardest question. What is 24 over 4? 6. That makes sense, and this is how fast you can do it without multiplying or dividing by highest power of this and that and this and that. When you know speeds of functions, you use this knowledge, I guess, as like a cheat. I call it shortcuts, and my students, like in taking my calculus 1, 2, and 3, call it Julia shortcuts, and they just like it because it makes sense. It's faster. Yeah.
So for problems like number 3, the limit of x approaching infinity and approaching negative infinity, they're always the same.
Very good question. Do you guys know if I do minus infinity, will the answer be the same? What do you think? That's in your homework. Why do you think it's yes? Because it's what? Cancelled. I also would look at the powers. Those matter. The powers are even. Not evil, even. So x squared makes negative infinity, positive infinity, x to the 4 also. The other infinities do some kind of stuff, but again, they follow the leader. But I will show you example when it's not the case. Thank you for asking. You see, those, I can see who is doing homework, because that's what you have at home. Yeah.
So in the denominator, say if there was like a plus x squared that was outside of the square root, like would that?
Yeah, let's do that example, because I know you have it over there. I prepared to show you example from your homework. Example from your homework.
Ma'am,
Yes?
I'm like, it was from 16x to the 4 in the denominator. But ma'am, how can we ignore plus 3x squared? Because we always like take the square terms together. Like we can't break
Yeah,
it.
it's not, I can see your question. The question is good. How can we kick it out? It's not correct from algebra point of view. We don't do algebra here. That's a very good question. So this is not the algebraic step. It is dividing by the highest power of the numerator-denominator thing, and it's exactly how it works out if you simplify nicely. I'm using here something which I show you after this example, which is knowing speeds of functions. It's not algebra. It's knowing that this whole thing follows only the highest power inside of the square root. So this equal sign, actually this is the best way to explain it. The question he asked is very good, especially for people who struggle with algebra. This is not correct. Just remember that. This is not correct. That's what you're asking, which is a very decent question. But if I put limits at infinity, it's correct. So limiting position is completely different idea than just equal. At infinity, it is correct. That's what I'm trying to explain, that at infinity, the behaviors just explode and following the fastest function. But algebraically, you cannot just leave the one of the pieces. That makes sense, yeah.
Is square root of 16x to the fourth plus 3x squared equal to square root of 16x to the fourth plus like a separate square root of 3x squared?
Oh, very good question. No, so that's also not correct. Yeah, thank you for reminding. That is not correct either. Square root cannot be broken into pieces unless you factor it out. If it's multiplied inside, then I could do. If it's like this, then actually it's correct. But sums and quotients, unfortunately, cannot. And limits, that's why limits are so annoying and you don't like them, but they're so good in scientific applications. They take you wherever algebra cannot take. They take you to infinities. They take you to asymptotes. They take you into the middle of the explosion, and they do stuff like that. So that is my point here. I would erase this one not to mess up the notes. No, thank you. That's a very good question. Yes?
So basically the process is we just remove all the irrelevant infinities and then we're left with only the important ones?
Yep, exactly. The leaders, the fastest ones. Let's do this example from your homework. The square root 25x squared plus x minus 5x. People asked about this a lot in the office hours and in the forum. So check the forum. We solved lots of homework problems in the forum. If you plug in, it gives you infinity minus infinity, infinity minus infinity. And now you know this is not necessary, zero. Infinities grow with different speeds. If the first one is faster, it will be infinity. The second one is faster, it will be minus infinity. Both of the same will be 1 or even something completely different. So I always like explaining this idea. You have two black holes, they're both infinities, but they have different speeds. You cannot claim that one black hole minus another black hole is 0. So it's hard for the brain to get used to infinities mathematically, but that just explains some infinitely growing processes, plus or minus. But how fast they grow, that is a different question. So it's not 0, okay? Just so that's not how it works. What you do here is your favorite, multiply and divide by the conjugate. Yeah, like you see square root, you just have a habit. You see square root, probably it is about the conjugate thing. Plus x plus, conjugate means you change the number. What did I say? Conjugate means you change the sign. So it's going to be plus. You multiply and you divide. Because you want to get rid of the square root. And to get rid of the square root, you like the formula. The formula says a minus b times a plus b gives you a squared minus b squared. Put a limit. X approaches infinity. A squared is a square root squared. So it's exactly what we wanted. It gets rid of the square root. That's a minus b squared, 25x squared, all over, so that's my a squared b squared, a squared b squared, but there's still like a whole thing now in the denominator. That's fine, let's keep it there. Actually, that's fine. Let's keep the pink color. Plus 5x. Too fast? I'm going fast because I assume you know this material. The conjugate comes from the previous homework. It's going to be on your quiz on Friday, so I assume you're good with conjugates. Are you? Now you see the top simplifies nicely. 25x squared and minus 25x squared leaves you with limit just x, and then you copy everything fast. 25 will go fast. Who is faster? Go. We have this. And now this is when the book tells you should start factoring, and you can cancel out the x, but also you can divide by the x with the highest power. So that's what I'm trying to tell you. Let's not do that. Let's be fast. Let's find the leader of the top. I mean, it's only x, so that was not very hard. X is its own leader by itself. The leader of the bottom, what do you think? 25x squared inside of the square root, right? So I will circle a square root as well. But 25x squared has a speed 5x. Does anyone else there has speed x? This one. So you keep leaders if they have the same speed. Make sense? One speed was hidden in the square root, but the other one is outside, so we keep both. Why I don't keep this x? Like she just said, we keep x power. So why we don't keep that one? It's a square root of x. Square root of x is slower than x. Does that make sense? So that's the idea here. So you can write down equal sign if you want and simplify. I will do it for you right now. But the leader of the top has a speed 1 times x. The leader of the bottom has the speed 5 plus 5. So it's 10 times x. What's the answer? 1 over 10. You see, you just skipped 5 steps. And that's the idea. Let me write it down so you are on board with what I just said. X square root of 25x, and also you have good notes, x squared plus 5x. Simplify, limit x 5x plus 5x. You have to write down limits everywhere, or else you cannot do equal signs, like we just mentioned before. You have x over 10x. It's 1 over 10. So all those 3 steps I just wrote down can be skipped if you understand speeds of functions. The speed of the whole fraction was definitely x at the top and x at the bottom. The powers are the same, so you just need to calculate the coefficients in front of them. And coefficients in front of them are 1 and then square root of 25 plus 5, and that is the answer. So that's 5 plus 5, which is 10. Isn't cool? Yes.
Can you please explain again that why you left x and chose 5x?
Yeah, so x, I left this guy because it's a square root of x. Since it's inside of the square root, let me do it like this. It's inside of the square root, so it's slower than others.
So ma'am, in last question you just ma'am
Oh yeah, I see your point.
Squared. In the last question it was 3x squared, that was x squared, and that would come out as x.
Let's see.
Then you left x squared to here.
So that's a good question. Thank you. In the last question, why?
We can generalize it as like the second term or the third term in
Yeah.
the root will be like.
So let me tell you. So are you asking about this one, right? Yes. So why did we not do the same thing here? Does anyone know?
It's not the leader
It's not the but how do you know? Like that's what he's asking. How do you know it's not the leader though?
because it doesn't have the largest coefficient.
The largest coefficient, yes. How about you?
Square root of 3x squared is root 3x.
Exactly. Same idea with the x. Good job. Same idea with the x in this new example. It's actually a square root of 3x. Square root of 3x is slower than 4x squared. That's why. So I'm comparing all the terms. I compare all the terms. This inequality is not correct from algebra point of view, but it is correct from the limit point of view. So I'm comparing and I see that this guy is slower than this guy, so I don't need to keep taking it with me. But actually, to be honest, if you even take it with you, the answer will still be the same, because you're gonna plug infinity and then the answer will show you that other functions are faster. Does that make sense? Or it's made it more confusing? Yeah.
So ma'am, can we say like in the root, as we choose the leader term, the other terms would be less than the leader term. So we can always like ignore the other terms, like specifically in the root, and take the terms which are outside of the root, like we took.
Yeah. Let's me repeat what he said. So good. That's very good way to say it. We ignore all these other things, in the root if they are slower, but then don't forget to check what's outside. If the guy outside is x squared and we're talking about x squares, then yeah, you have to keep it. If the guy outside is even faster, then definitely have to keep it. So we're throwing away things which are slower, but not the one that's faster or the same speed. Just a second. Oh. Yes?
So, as opposed to saying that we are canceling out the 3x, would it be better to say we're ignoring the 3x?
Yeah, ignoring. Yeah, it's good. Thank you. Ignoring, not choosing. Yeah,
And
yes.
also, for limit x goes to infinity, the square root 25x plus x example, why did we have to conjugate it at all if we could just do the whole find the leader thing right from the beginning?
Yeah, so what do you think the answer will be? It was without the conjugate. So the question is good. Why do we have to do the conjugate? Why not just to find the leader? What do you think the answer will be though? If I just choose the leader, it's going to be 5x minus 5x, and it gives you 0. So we're going to learn in this class, infinity minus infinity is not necessarily 0. This trick helps you to create a fraction. And when we see ratios, then we can find the ratios.
Infinity minus infinity isn't necessarily 0.
Not necessarily 0,
but
yeah.
Ratios are
Ratio, we know ratios, yeah.
Okay.
It's always actually, ratios and products are good. Sums and differences are hard to work with. Yeah?
So how different is f of x with infinity as a function?
Uh-huh.
And f.
Oh, I know what you mean. So when the answer is infinity, right?
Right.
Yeah.
How different is it?
Let's. Oh, it's actually was question in the front. So let me see if I have time to go to this. Let me show you. Oh, let me show you actually a funny example, and then I will move on to the next chapter. Good job, people. Definitely, it's super fun that you're asking good questions. I like all the synonyms people gave me. We're ignoring them. We don't use them. Find only the leader. Do you know the answer for this question? Okay, people who did homework, don't tell anyone. Just say, don't be the smartass. I always like to say it. So, cosine and infinity. What do you think is doing? You know, like a cosine is an infinite wave, right? And sine is also infinite wave. It's just shifted. Look how beautiful it is. So cosine is an infinite wave, right? At infinity, what does it do? That's your homework question. Sometimes I put it on the test as well. Yes. Actually, that's when you can try to find limit from the left and limit from the right and see what's happening. But it's not 0 here, not 5. It's at infinity. In the long run, cosine is... So what is cosine at 1,000,000? Some kind of number. What is cosine at 10 millions? Some kind of another number. What is cosine at 1 billion? Some kind of another number, which tells you cosine cannot decide where to stop or where to go. Cosine always stuck between -1 and 1. In this case, -5 and 5. So it will wiggle forever. That means there is no limit. It just never stops going. Isn't it cool? So not the infinite behaviors, not necessarily infinities. That's kind of how interesting this case is. It's infinitely proceeding, but it's not going up to give you infinity. It's not going down to give you minus infinity. And it doesn't stuck at any asymptote either. It's just doing its thing. It just keeps going as an infinite wave. Isn't it cool? So that's, I think, is a pretty interesting concept. Yes?
Is this the same for sine and tangent?
Sine, tangent has asymptotes.
Okay.
Yeah, remember it's lots of chairs with walls. Yeah. So infinities and minus infinities. Let me help you with other questions through homework and forum, especially the left limit and right limit. But basically, if you want to know if it's minus infinity or plus infinity, like in this case, is it D and E plus or minus infinity? You have to check what's happening from the left, what's happening from the right. Like tangent, tangent around pi over 4, pi over 2, what is happening there? Do you guys have questions? It's a little bit distracting. Ask me if you want to ask. The cosine?
Yeah.
Oh, yeah.
We just grab one.
Yeah, that's good. Remember how it starts. I remember that sine starts at 0 and go up. Cosine starts not at 0 and go down. And then from there, they are the same. They just keep going. So what I want to say, okay, I wanted to say this thing so you remember this idea. I even have a picture for you and then we can move on. So again, vertical asymptotes and horizontal asymptotes. You don't have to copy this. Horizontal asymptote can be crossed, as I showed you here. See? But vertical asymptote cannot be crossed. The function is not defined there. So if they ask you f or at a, the answer is, I don't know, it doesn't exist, it's not defined. So to remember this, I always mention that this is the wall, this is the wall, and you shall not pass the wall. Okay, you shall not pass this wall. Shall not pass. And that's how you remember which one is which. Vertical wall, you should not pass it. That's wrong. While horizontal wall, sometimes functions wiggle around and then stuck. So that is fine. If you ever see it, you will see it's fine. Not too bad. Finally, I will mention this a little bit later in other classes so I can show you more for your homework. Oh, this is what you wrote down, remember? So if you miss it, this is basically the summary of what I just said. Number over infinity gives you 0. That's a good case. Infinity over number, that's infinity. Just keep an eye on the constants. Number over 0 plus or minus infinity, or D and E if left limit did not meet with the right limit. If left limit did not meet with the right limit. And that's how you can make your homework go fast. What do you think about this? Kind of thinking to show you one more example or proceed with a derivative. I guess let me proceed with a derivative and then we're going to do lots of weird algebra on Friday. Yes? So this is good for the 1.6.